Good evening, friends. In the last class, we seen about the mathematical reasoning. The mathematical reasoning, including of simple statement, compound statement. When the statement is nothing but proposition, we now understand that that statement is a division of nearly 5 forms. The logical concept, number one, negation, number two, and or conditional and pi conditional, conditional and pi conditional. And one more thing, it is very important, tautology also used here. This mathematical reasoning, the including of properties of idempotent laws, commutative laws, identity laws, associative laws, distribution laws, De Morgan laws. These are comes together to solving the problem. The mainly in the chapter to explains about truth table, based on truth table. Here mainly in the truth table, including of two terms. One it is positive, another it is negative. To simply is known as truth and false. So and logical operation how to operate, or logical operation how to operate, negation how to operate, and then conditional and pi conditional how to operate. These are we can use in solving the problems. Now we are going to the first problem. Which of the following is tautology? Which of the following is tautology? Which of the following is tautology? In the first option, the second option, in third option, in fourth option, in four option given here, which one is comes under the which of the following is tautology? We now understand that to prove the tautology in this given option, to using the truth table, the mainly the first one I must take. What is the first one? Now to form the truth table, P, Q, negation of P, negation of Q, and P tends to Q, P, and next one and last one Q. Now in this problem, let us take in first option. We know, understand that using the tautology, using the truth table to find out to which of the option is comes under the tautology. In 4 options given here, now I take first option to frame the truth table. True, 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 false, false, true, false, false. That is called a to input. Then negation. False, false, truth, truth. Because the negation of P. Next one, the negation of Q. False, truth, false, truth. The first one, 2 initial input. Here in 4 input is given to check the tautology. The mainly the P with T, 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 false, false. Q, true, false, true, false. Or otherwise, to give the input to initially true, true, it used to be PVQ. So the V is nothing but what? V is OR gate. So PVQ, T, true, true, false. Because this is a OR. Next one AND. The AND is what? T, false, false, false. We know, understand that the negation P bracket AND operation, the bracket of P or Q. We know that to take first 2 inputs, the negation of P, false, false, true, true. The negation of Q, false, true, false, true. Next one, the addition of P and Q, P or Q. Next one, the AND operation, truth, false, false, false. The next one, P tends to Q. True, false, true, true. We now understand that P here, Q here, here T, truth. Here false, false. True, true. Both false, true. Both false, true. The next one, truth, truth, false, truth. The next one what? Truth, truth, false, truth. The next one what? Truth, truth, false, truth. Truth, truth, false, truth. The first one, PQ. So here, truth, false, false, truth, truth, false and false, truth. Next one, truth, truth, false, truth. In both are false, it comes under the truth. The both are false, comes under the truth. And next one, false, false, truth, false. False, false, truth, false. False, false, truth, false. And last one, truth, truth, truth. All output is truth. Here, the negation of P. Next one, OR operation. This one, this one. The next one what? The Q1. Truth, false, truth, truth, truth. Everyone comes under the truth. Everyone comes under the truth. Everyone comes under the problem. Second problem, the negation of statement. Negation of statement. Root 5 is an integer. Root 5 is an integer. Or 5 is an irrational. Irrational is the negation of statement. The root 5 is an integer or 5 is an irrational is. The first option, the root 5 is an irrational or phi is an integers. Root phi is an not integers. It's not integers. Not integers, or phi is not irrational. In third option, irrational. Phi is on what? Irrational. And D option, root phi is it on integers, and phi is not irrational. Understand that the phi is comes under the root side, root inside. Is it possible for fraction or decimal point? And definitely the phi is whole number. But in mention here is not irrational. So the D option is correct. The root phi is it on integers, and phi is not irrational. Phi is not irrational. The next problem. Following statement. Consider the following statement. The first statement, Suman is brilliant. Suman is brilliant. And second statement, Suman is rich. And third statement, Suman is honest. Consider the following statement. The first statement, Suman is brilliant. The second statement, Suman is rich. And third statement, Suman is honest. The negation of statement, the negation of statement, the negation of statement, the Suman is brilliant and dishonest. And what? Dishonest. Suman is brilliant and dishonest. If and only if Suman is rich Someone is rich can be expressed as. Can be expressed as. So consider the following statement. The first statement, someone is brilliant. The second statement, someone is rich. The third statement, someone is honest. The negation of statement, someone is brilliant and dishonest. If and only if someone is rich, if and only if someone is rich can be expressed as. The option, the first one, in second one, on third one, the someone is brilliant and dishonest. Dishonest. Someone is brilliant and dishonest if and only if and only if and only if someone is rich. Someone is, then I will open a school is. The negation of statement, if I became a teacher, then I will open a school is. The option, I will become a teacher I will become a teacher and I will not I will not open a school. In first option, the given statement is, if I became a teacher, then I will open a school. In this question paper, related option first one, I will become a teacher and I will not open a school. In second one, either I will not become a teacher, or I will not open the school. I will not open a school. I will not open a school. And third one, neither I will become a teacher, nor I will open a school. Nor I will open a school. And fourth one, I will not become a teacher. I will not become a teacher, or I will open a school. I will open a school. So the negation of statement, the given statement, if I became a teacher, then I will open a school, is the first one. The negation of given statement, I will become a teacher and I will not open a school. And second one, either I will not become a teacher or I will not open a school. And third one, neither I will become a teacher nor I will open a school. And fourth one, I will not become a teacher or I will open a school. The first option, either I will not become a teacher or I will not open a school. Here mentioned that I will become a teacher and I will not open a school. But if I became a teacher, then I will open a school. The negation of given statement, in absolutely the first option is correct. Here, I will become a teacher and I will not open a school. But the next one, either I will not become a teacher or I will not open a school. In third one, neither I will become a teacher nor I will open a school. And fourth one, I will not become a teacher or I will open a school. So here, very appropriate option is first one, because I will become a teacher and I will not open a school. The next question, the statement equivalent to in second one equivalent to in third one in fourth one your statement negation P and negation Q is equivalent to here tautology fallacy. We know compare the option the given questions first to frame truth table. What is the first one? First one P, second one Q, the negation of P and negation of Q. Now we can write here truth, 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 false, false, truth, false, false. Truth, 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 false, false, truth, false, false. The negation of P, false, false, truth, truth. The negation of Q, false, truth, false, truth. The next one, false, false, truth, truth. And next one, truth, truth, false, false. And next one, truth, truth, false, false. Truth, truth, false, false. And next one, false, false, truth, truth. False, false, truth, truth. Here, the statement is equivalent to. The statement is equivalent to. It's a tautology, fallacy, equivalent to, and equivalent to negation of P. Here, the first one is very correct. The first one is very correct. The next one, contra positive of this statement. Contra positive. Contra positive of the statement. Contra positive of the statement. If a function f is, if function f is differentiable, differentiable at A, then it is also continuous. Then it is also continuous. Also continuous at A is. The first one, so mainly this equation if a function not differentiable, not differentiable A and not continuous of A. We now understand that in the mathematical reasoning, the including of simple statement, compound statement, tautology, negation, and are conditional and biconditional. And moreover, here the identity loss, idempotent loss, associative loss, distributive loss, commutative loss, De-Morgan loss. These are we can use in solving the based on truth table. In the mainly the based on question papers in tautologies, here two statement is given or one statement is given to write the negation of above statement. How to write any positive statement is equivalent to negative statement. We are using the truth table based on and or negation. These are solving the based on truth table given statement is whether it is correct or not, and one more thing, this statement is negation of another statement. So mainly this is and or operation. So this correctly equivalent to electronic circuits also.